Welcome back to The Explainer. Okay, I am absolutely thrilled you're here with us today because we're looking at something that honestly feels like pure science fiction, but it's rapidly, and I mean literally rapidly, becoming our everyday reality. For centuries, humanity has been completely captivated by this one incredible dream, creating artificial life. And what started as basically ancient myths whispered around fires, well, it's transformed right before our eyes into an urgent, modern demographic necessity. So today, we're unpacking the past, the present, and the absolutely wild future of humanoid robots. Let's dive in. All right, I want to hook you immediately with this staggering number, 3 billion. Yeah, according to recent research, by the year 2060, there could potentially be 3 billion humanoid robots seamlessly integrated into our society. I mean, just think about that for a second. We're talking about machines walking right beside us, working in our homes, staffing our industries. It's not just a distant fantasy anymore. It's a statistical projection based on the massive investments happening right now. But, to understand how we're actually going to reach 3 billion, we kind of need to understand where the whole shebang started. Because our fascination with creating artificial life really not new. Back in Greek antiquity, we had the mythical Talos, this giant bronze guardian. Then fast forward to the 15th century, and the brilliant polymath Leonardo da Vinci actually designed a mechanical knight. It could sit up and wave its arms using these really complex gears. Honestly, the word robot itself wasn't even coined until 1921 in a Czech play called RUR, which, fun fact, actually warned of artificial workers rebelling against humans. But the real turning point, from pure imagination to actual reality, that happened in 1954 with Unitree, the world's very first programmable robotic arm. And that 1954 invention, it fundamentally changed the world. By 1961, early industrial robots were deployed on factory floors, places like General Motors. But here's the thing, these early bots were literally bolted to the floor. They had to be separated from human workers by heavy fences. Sure, they performed tireless, repetitive tasks like welding car parts day and night, but they had absolutely zero intelligence. No eyes to see, no ears to hear. They were just pure programmed muscle. And for decades, that was basically the status quo. Robots stayed in the factories. Which brings us to Section 1, the plot twist. Why we need robots now. So, we're pivoting sharply here, because the narrative has completely shifted. We are no longer building humanoid robots just to satisfy some historical fascination with machines or just to do dangerous factory work. We're building them to solve a very pressing, very sudden, and very global crisis. So I want you to ask yourself, why the sudden rush for humanoid robots? Why are the biggest tech giants and auto manufacturers in the world suddenly pouring billions with a B into a frantic race to build bipedal walking machines right this second? What changed? Well, the answer isn't just technological advancement, it's actually demographic survival. Here is the aha moment driving this entire industry. Take a look at this UN baseline projection. Across the developed world and increasingly in emerging markets, a 2-century-long trend of population growth is just completely reversing. Birth rates are plummeting, and, when the population shrinks, the traditional human workforce shrinks right along with it. So the absolutely crucial takeaway here is this. We are facing an unprecedented global labor shortage. Modern economies completely rely on sustained consumption and productivity just to survive. If you have fewer humans to actually do the work, productivity collapses. So humanoid robots, they're no longer just this sci-fi fantasy for us to marvel at. They are an inevitable economic solution. They are essentially the only way we'll be able to sustain human productivity during this massive demographic shift. They're being built to step into the exact roles humans are leaving empty. Which naturally brings us to how we're actually making this happen so fast. Moving right into Section 2, building the modern humanoid. It's all about this incredible combination of unprecedented brain and brawn. On one side, we've got these massive leaps in physical engineering. Better sensors, lighter materials, super agile joints that allow machines like Boston Dynamics' Atlas to run, jump, and even do backflips. But the real game changer, that's on the cognitive intelligence side. Advances in large language models, or LLMs, are paving the way toward artificial general intelligence. We are literally putting ChatGPT-like brains into human-like bodies. This allows them to understand natural language, learn from just watching us, and actually adapt to chaotic, unpredictable human environments. Now, if you're sitting there thinking this technology is going to remain some luxury item reserved for multi-billion-dollar corporations, get a load of this number, $5,500. Yeah, this is the shocking reality. Complex humanoid models, like China's Unitree R1, can already be purchased right now for as little as $5,500. That is roughly the cost of a high-end laptop or a decent used car, and you can literally buy a bipedal robot. Crazy, right? So how is a price drop like that even possible? Well, it's because massive automotive companies, entities like Tesla, BMW, and Hyundai, who have literally spent a century perfecting mass production and assembly lines, have entered the chat. They're applying car manufacturing economies of scale directly to humanoid robots. Because of this, analysts project that raw material costs for building a humanoid will plummet below $17,000 by 2030 as millions of units start rolling off the lines. And plunging costs plus urgent economic necessity equals one thing: a really intense, high-stakes geopolitical race. Which takes us to Section 3, the global robotics race. Take a look at the top 5 countries investing most heavily in innovating and utilizing robotics right now: China, South Korea, Japan, Germany, and the United States. Do you notice a trend here? Aside from being absolute industrial powerhouses, these are nations facing incredibly steep population declines and aging demographics. They're pouring resources into robotics out of sheer necessity, just to offset their shrinking human workforce and maintain their industrial dominance on the world stage. And this brings us to a really critical geopolitical dynamic, especially between the US and China. China currently appears poised to lead the field in humanoid robotics, integrating them super heavily into their strategic economic plans. Meanwhile, the United States is rapidly accelerating its own investments, backed by heavy hitters in the AI space. This intense technological race between these two nations is absolutely going to drive up global demand for critical minerals and semiconductors. It's a fierce competition for both the hardware and the software that will power the 21st century economy, raising tensions over supply chains worldwide. But bringing 3 billion intelligent mobile machines into our world isn't just an economic shift. It brings some truly unprecedented challenges. Let's get into Section 4, risks in the robotic age. The cybersecurity vulnerabilities are, frankly, terrifying. Think about it. A laptop getting hacked is bad, sure, but a 150-pound bipedal robot in your living room getting hacked, that's a direct physical threat. These robots could potentially be hijacked to cause physical harm. Plus, they're packed with cameras and microphones, making them prime targets for severe data leaks and cyber espionage. They could even be networked together by bad actors to form physical botnets. We absolutely, urgently need to treat humanoids with the strictest cybersecurity standards imaginable. And beyond security, we have to navigate a profound ethical minefield here. On one hand, using robots for elder care, rehabilitation, or even companionship can bring incredible benefits to an aging population that simply doesn't have enough human caregivers. But on the flip side, what are the ethical risks? Are we risking severe human isolation? Can people form genuine emotional attachments to non-human entities? And really, how much absolute privacy are we willing to erode by having a constant internet-connected observer living right beside us? To bring this explainer full circle, just take a look at this incredibly striking image of a modern humanoid robot. It's uncanny, isn't it? It really reminds us that Leonardo da Vinci's 15th century dream, that mechanical knight we talked about, is no longer just a sketch on parchment. It is a tangible reality, made of sleek metal and powered by advanced neural networks, literally preparing to walk among us. The timeline of human history is entering a totally uncharted chapter, where the line between biological and mechanical is fundamentally blurring. So I want to leave you with this final, provocative thought to chew on. As we usher in this age of the humanoid assistant, we have a massive choice to make. Are we building partners to share our future, or a force that we need to constantly control? The machines are ready. The real question is, are we? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I will catch you next time.